Okay, going on to unit 1.4, which is Radian measure and trig functions. So under Radian measure, you have to know that in WTW 158 we will be using radians instead of degrees. So you must be able to convert from radians to degrees and vice versa, so that everything becomes easier for you. So how to do the conversion? You have to know that pi, which is pi radians, is equal to 180 degrees, and 2 pi is equal to 360 degrees. So if you know these two, then everything else will be quite simple. So I'm just going to show you how to convert some simple angles, and then we'll move on. Okay, so for example, if we are required to convert 300 degrees to radians, so you can just use ratios. So 2 pi is equal to 360. What about 300? So this will be less. So you have 300 over 360 times 2 pi. And that cancels that. 6, that's 5. Then that's 3, that's 1. So it's 5 pi over 3 radians. So you can use simple ratios, simple proportions, and then it will be easier for you. So let's just convert an angle in radians to an angle in degrees. So I'm going to use 3 pi over 8. So we know that 2 pi is equal to 360 degrees. What about an angle less than 2 pi? It has to be less as well. So it's 3 pi over 8 over 2 pi times 360 degrees, and then that will give us 3 pi over 16 pi times 360 degrees, and pi cancel. You divide by 4, becomes 4, and then this one becomes 90, and divide by 2, it's 45. 45 by 3, that will be equal to 135. Will be 135 degrees over 2, which is equal to 67.5 degrees. So that is how you do the conversions. Okay, so moving on, you now have to know how to sketch the angles. So I'm going to show you how to sketch a few simple angles. So for example, sketch 2 pi over 3, negative 4 pi over 3, 9 pi over 4. Okay, so before we do all that sketching, you have to know, like if you have a Cartesian like that, then over here you have pi over 2, you have pi 0, you have 3 pi over 2. So if you're going in an anti-clockwise direction, you're going on the positive, that's positive. If you're going clockwise direction, then that's negative. So this is also a negative pi over 2, this negative pi, this one negative 3 pi over 2. Okay, so sketching 2 pi over 3. So 2 pi over 3, that's greater than pi over 2. So we're going to find it somewhere over here. And it's somewhere over there. That, and then that's going to be pi over 6. So we can draw that. So that will show you 2 pi over 3. Because 2 pi over 3 is pi over 2 plus pi over 6. Then you get 2 pi over 3. So this would be your angle 2 pi over 3. And then negative 4 pi over 3. So that's an angle greater than negative pi. And it is greater than negative pi by pi over 3. So it's less than less than negative 3 pi over 2. So it will also be in this quadrant. So these are called quadrants. So it will be in this quadrant over here. So but then when you're now drawing an angle, draw it like that, just to show that there's negative 4 pi over 3. So you can draw it coming from this direction, and so it's less than negative 3 pi over 2 by pi over 6. So it will still be over here as well. So this will be angle negative 4 pi over 3. So this angle can be written to negative 4 pi over 3. And then the last one, 9 pi over 4. So 9 pi over 4, as you can see, it's 2 and so it's 2 pi and pi over 4. So if you go one full rotation, then you're also at 2 pi. So now it's just 2 pi. So you're 2 pi and then 8 pi over 4, and pi over 4 just over there. So this is your pi over 4. So this one can be a 9 pi over 4. So you just have to know the basic angles, like these ones: pi over 2, pi over 4, pi over 3, pi over 6, 3 pi over 2, and 2 pi. Everything else is just a repetition of these angles. For example, 9 pi is a combination of 2 pi and pi over 4. So it's these two to make up this one. And then negative 4 over 3 is just a continuation of this pi over 3, but then you're moving it anti-clockwise, in the clockwise direction, up until you reach negative 4 pi over 3. So once you get to be able to sketch these angles, and you know these angles by head, and you can do the conversion, then you are safe with radian measure. So moving on to trig functions. So I just call them trig functions in short, because trigonometric, it's quite a long word. Okay, and then so we have our triangle, a right angle triangle with an acute angle theta over there. So this is called the hypotenuse. That's the opposite because it's opposite to the angle, and then that's the adjacent to the angle. Okay, so basically I have 6 trig functions that you just have to know, because if you know those 6 trig functions, then you can work out everything else. Okay, so we have the first two, sine theta and cos theta. So sine theta is formed by saying opposite over the hypotenuse. So if you have this length, then you can get sine theta. Then cos theta is adjacent over hypotenuse. So if you have that length and that length, then you can find cos theta. And tan theta is also equal to sine theta over cos theta. And so it basically comes down to opposite over adjacent. And then sec theta now. So these are additional trig functions to make them 6. So it's these 3, and then the other 3 are just composites of these 3. So sec theta is just 1 over cos theta. So sec cos theta. So 1 over cos theta, which means it becomes hypotenuse over adjacent. And then cosec theta is 1 over sine theta, which basically becomes hypotenuse over opposite. And then cot theta is 1 over tan theta, hence it becomes adjacent over opposite. So it's just the inverse of this one. Okay, so now you just have to know the signs of your trig functions in each of the 4 quadrants. So if quadrant number 1, 2, 3, and 4. So quadrants are measured going in an anti-clockwise direction. So in quadrant 1, all the trig functions are positive. So positive everything. So it's all the trig functions are positive. So your sine, if you get a sine of any angle within this quadrant between 0 and pi over 2, then everything's going to be positive. And then in the second quadrant, only sine is positive and everything else is negative. So if you have like the sine of 2 pi over 3, it's going to be positive, and cos 2 pi over 3 now is going to be negative. Tan 2 pi over 3 is going to be negative. And then in the third quadrant, only tan is positive, because you're going to have negative sine and negative cos, and negative over negative, it's just going to be positive. So only tan is negative, and sine and cos only sine is positive, only tan is positive, and sine and cos are negative. In the fourth quadrant, fourth and final quadrant, only cos is positive, so tan and sine are negative in here as well. Okay, so one more thing, according to your study guide, you must memorize, you must know and be able to use the identities 6 to 13 and 15 and 16 on page appendix 28 to appendix 29 in Stuart. So please do memorize these identities so that when it comes to test and exam situation, you won't be surprised to find those identities in there, and be able to use them, especially when solving equations, trig equations. You need to use the identities to make everything simpler. Okay, so the last thing on the theory part, you also need to know the trig functions of those angles that I told you to memorize. So if you do know the trig functions of the angles that you're supposed to memorize, then all the other angles are built upon those main angles. So you can now just derive to see where it will be, then so it'll be just a change of sign only. So now moving on to the questions. So the basic question will be find without using a calculator, then equation like sine 7 pi over 4. So obviously we've established that in WTW 158 you're not going to be using calculators, so you just need to memorize the trig functions of the most important angles, the ones that you're supposed to memorize, and then afterwards you actually see that everything else just falls into place. So sine 7 pi over 4, 7 pi over 4 is going to be in this quadrant. So the first thing that you can do is just write your O sine tan C. So you can use all silly tomcats to just remember these. Okay, so only cos is positive in this, so sine is going to be negative. So in our particular case, we can already write that it's negative something. Okay, so to now get the value, just use our main angle would be pi over 4, this one. So sine of pi over 4, that one, if you would have memorized the angles, you know it's 1 over root 2. The same as cos of pi over 4, it's 1 over root 2. So now all these are the numbers are just helping you to get the sign, to see in which quadrant it is and what sign to put in front of our number. So sine 7 pi over 4 is equal to negative 1 over root 2. And moving on to the next one, sec 5 pi over 3. So sec 5 pi over 3, we said sec is just equal to 1 over cos 5 pi over 3. So the main angle that you have to know is pi over 3. And now to just check where 5 pi over 3 is going to be. So over here we're going to have pi, and then here we have 3 pi over 2 and pi over 2, like that. So 5 pi over 3 is going to be greater than pi, and also greater than 3 pi over 2. So it's going to be in this quadrant. So it's the fourth quadrant. So we already know that it's going to be positive since cos is positive. So it's going to be positive. And then to now check what is pi over 3. Pi over 3, if you've memorized everything, you're going to see that it's, so we're going to have 1 over, so cos of 5 pi over 3, cos of pi over 3 is just 1 over 2, so it's a half. So 1 over 2 is just going to be equal to 2. So 2 will be your final solution. So you just see that if you know your main angles, pi over 3, pi over 2, pi over 4, pi over 6, etc., then you can easily do all the other angles. So the next one is cos of negative 15 pi over 3. So cos of negative 15 pi over 3. Our main angle is pi over 3 again. Then it says negative 15 pi. Okay, so 15 pi over 3. That's just equal to negative 5 pi. So negative 5 pi, so there's negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi. We're over here. So it's basically cos because of pi. So we can just rewrite this as cos of pi. That's equal to negative 1. So just mainly focusing on your main angles, although in this particular case, you're just going to have to reduce it, and so that everything becomes easier and you end up over here. But for everything else, you see that we've been dealing with our main angles only. So please do know all your main angles and their trig functions. Okay, so the next part of the question says, it's still fine without using a calculator. Sine theta, tan theta, sec theta, and cosec theta if cos theta is equal to negative 4 over 5. So with this one, what we're going to do is draw a triangle so that we can put in these values. Okay, so on our triangle, we have theta over there, that's 90 degrees. And then cos, we know that it's adjacent over hypotenuse. So this is your 5, this is your 4, that's your 5. And if you use Pythagoras, you're going to get that one as 3. Okay, so we're given the quadrant it is in. Okay, so it's pi over 2 to pi. So it's in this quadrant, in the second quadrant. That's why your cos is negative, because only sine is positive in it. Or silly tomcats. Okay, so find sine theta. Sine theta is opposite over hypotenuse. So sine theta is equal to 3 over 5, and it's positive because sine is positive in the second quadrant. And then tan theta is equal to opposite over adjacent. So it's 3 over 4, but it's negative since only sine is positive in the second quadrant. And then sec theta is equal to 1 over cos theta, which means negative 5 over 4, because we already have cos theta. And then cosec theta is equal to 1 over sine theta, which is equal to 5 over 3, because we already have sine. So it's 1 over 3 over 5, which becomes 5 over 3. So these are your solutions. So you just have to start off by drawing the triangle. So when you're given a trig function of theta, and you're given the values, you can just draw a triangle and then work everything else out. Okay, so last question says sine theta, tan theta, cot theta, and cosec theta if cos theta is equal to negative 1 and theta is between pi over 2 and 3 pi over 2. So we're using quadrant number 2, quadrant number 3, because this is 3 pi over 2, that's pi over 2. So we're in this quadrant, we're in these two quadrants with sine and tan positive. Okay, so we're given cos theta is equal to -1. We draw a triangle. So we know the cos is adjacent over hypotenuse. So for us to get a -1, 1 and 1 over here. And if we use the Pythagoras theorem, this would be a 0. And then that would be your theta. So cos theta will be -1. And then tan theta, sine theta is opposite. So sine theta, which is equal to opposite over hypotenuse. So it's 0 over 1, so it's just 0. Then tan theta is just, which is equal to sine theta over cos theta is 0 over -1, so it's 0 as well. And then cot theta is equal to 1 over tan theta. But tan theta is 0, so our cot theta becomes 1 over 0, which is not defined, undefined. And cosec theta is equal to 1 over sine theta. It is also undefined because it's 1 over 0. So this is how you go about such questions if you are to meet, if you're to be given them in the exam or test. So these are the procedures that you're just going to follow. Okay, so for questions involving equations and inequalities, you'll be given something like this, and then the question will say, find all values of x in the interval 0 to pi to 2 pi that satisfy the following equation. And this is our following equation. So we need x values from 0 to 2 pi. Okay, so what you have to first of all do is to find the principal value. So that is like the first value of x that you can just attain from just looking at this equation. So we're going to have cos 2 cos x being equal to 1, and then cos x being equal to a half. So you need to find x being equal to a cos of a half. Therefore your x will be equal to pi over 3. So this is called your principal value because this is your first value, and cos repeats itself after every 180 degrees. So you're going to get a half after every 180 degrees. Okay, so over here we have our pi over 3, so you have to get our 180 and be x go to pi over 3, and then after 180 degrees, so it's plus pi, it becomes 5 pi over 3. And then so I actually see that it's only these two that fit in the range that we're given, 0 to 2 pi. So these would be your solutions. But if you're to be asked to look for a more general solution, then you go like x is equal to pi over 3. So okay, so it's 2 pi n plus or minus pi over 3. So this one can go negative. You can start off at negative pi over 3. So again, and your n values will be running from 0, 1, 2, and so forth, going on up. So it's, in this particular case, we are only required to find between 0 and 2 pi. We have only pi over 3 and 5 pi over 3. That will be your solution. So what you just need to do is first of all find the principal value, and then you check how frequently your function repeats itself. For example, for cos, it's going to be after every 180 degrees. So So if you have the first value over here, then after 180 degrees you're going to be over there. After another 180 degrees you'll be thing on 7 pi over 3, which is now out of the range. So you just look at you also look at the range that you're given. And that will be it for unit 1.4. So it's basically how to convert degrees to radians, your trig functions, and please do memorize those trig functions of our most important angles. Then everything else you can just derive from it. And look at the trig identities in the appendix. Then you'll be set to go with theme 1.4.